Hey guys, Coach Dennis here. I'm here to talk about our learning target over petroleum and hydrocarbons. So our objective of these notes is being able to describe how petroleum is going to be separated into different products. So everything from plastics to man-made fibers, gasoline, diesel, all those things that come with crude oil and distilling that crude oil. So our definition of a hydrocarbon is hopefully pretty obvious, coming from the name, is molecules that are made up of hydrogen and carbon. Petroleum, which actually if you go over across the pond in the UK, that's generally what they call gasoline, is a liquid hydrocarbon that is pumped out of the ground as crude oil. So that's what we initially start with, and then eventually we're going to have to refine that to get what we need out of it. So how we refine that is separating it using what we call distillation. So when you distill something, you start to boil it, and depending on what temperature it boils at, that's what product is going to be given off. So some examples are like gasoline, kerosene, which you don't see as much. That used to be a major, like within major product for like lamp fuel, diesel fuel in trucks, and then paraffin wax. So like your general wax that makes up candles. But it's also used to make plastics, medicines, and different man-made fibers, such as like what's in carpeting. So hydrocarbons are made up of hydrogen and carbon. Generally, the more carbons you add, the higher the intermolecular forces. Also, the more energy they'll have, so they're going to stick together a little bit better. So if you think about gasoline's a liquid that, for the most part, that evaporates relatively easily. Whereas diesel's a little bit harder, whereas motor oil, which you know is a little bit thicker, it's going to be a little more together. And of course, plastic is very stuck together. You know, plastic like in a cup that I got right here. So most of our petroleum products, what we use them for is to burn them and use them for energy. So when you burn a hydrocarbon, it's going to produce energy. Also, you get water, and then the obvious one is carbon dioxide. 7% of our petroleum products end up being used for plastics and medicine, and then the last 4% are such as mechanical lubricants, so like what you think of as motor oil, bar oil, or you know, anything grease, anything to keep things lubed up, and then also asphalt, so your blacktops. So whenever we talk about petroleum, we also have to definitely talk about fossil fuels. So fossil fuels are any fuel that is made by the earth by breaking down plants and animals, and generally mostly plants. Most of our fossil fuels, like when it comes to crude oil, it comes from the Carboniferous period. So carbon is what starts it off because it has a lot of carbon within it. So the more carbon and hydrogen you have, the more energy it's going to have. So our fossil fuels include coal, which is generally a much harder form of our fossil fuels. Natural gas, which is the gaseous form, which usually is at the top of like a deposit. And then petroleum, which is like our liquid sludgy stuff that we get. And how we get our fossil fuels is over a long period of time. So this is why we consider it a non-renewable resource, because it generally takes millions of years to develop. And how we get it is by having these plants and animals under extreme heat and pressure. So under this heat and pressure and over years, it eventually turns into these different fossil fuels. This process, you know, it can take a very long time. It's, you know, I don't even really know the shortest amount of time it takes, but it takes, you know, millions of years to do, generally. So our petroleum distribution, as you can tell, we in the U.S., we generally use much more than any other country I mean, it's kind of how we have our cities designed. Like Kansas City in particular is a very spread out city. So in order to work in Kansas City, you have to be able to drive. In order to drive, you have to get gas. So uh, that's one reason why. Also, a lot of the industries that we have uh, use petroleum in some shape or form. However, even though we use a lot of petroleum, we are not ones that really make a ton of it. I mean, we've made more once we've had fracking and different things like that involved. But generally, most of our petroleum is going to be found within the Middle East. However, within the last like 10 years, there's been a lot that's found in, I believe, Venezuela and different South American countries. They found a lot of reserves. So this isn't completely up to date, but just overall, though, Middle East is going to produce the most or have the most reserves, whereas the U.S. generally uses the most. Now, if you look in Asia over here, they're starting to creep up there a little bit more, but they also have a very large population, so that makes sense. So whenever we talk about fossil fuels and burning them, we also have to talk about our carbon footprint. So what our carbon footprint is the amount of greenhouse gases made by your activities. So this could include, how much electricity you use at your house, because believe it or not, how our electricity is produced is using coal generally. It's within a coal generator, it generates the electricity, but uses the coal as the energy. So that's definitely going to leave a carbon footprint. How much gas you use when you drive. So if you have to drive a far distance to work, like probably some of your teachers, then you're going to have a larger carbon footprint because you're going to be burning more fossil fuels. Other things, if you think about it, also would be getting things delivered to your house. So you're going to have a larger carbon footprint if you get most things delivered to your house. And during this time, that's probably what a lot of people are doing. And then another major factor for carbon footprint is what waste do you use? Do you recycle it? So the more you recycle, the less carbon footprint you'll have. So you got to think about ways to reduce that as much as possible. So how we use crude oil and get all these different products from it is we use what we call distillation, and specifically fractal distillation. So distillation is where you separate liquids by their boiling point. So where you may have heard this before is like purifying water. So if I'm trying to distill water, I know I'm going to get water once I get it to 100 degrees Celsius. It's going to start boiling, and whatever gas that is given off is going to be that of pure water. And then eventually we condense it down. And how we condense it down is by putting it through a cold tube, and then it becomes that pure water. So what's a little bit different about distilling water to like crude oil is each time at each different level or different temperature, we're going to get different products. So at one temperature, we may get gasoline. Then the next temperature, we get diesel fuel. Then the next, we would get like different residues and waxes. So each temperature, you're going to be giving off different things. So here's some examples. So these are the 6 main fractions that you get from petroleum. So when you are under 40 degrees Celsius, so just to give you guys an idea, about 22 degrees Celsius is like room temperature, 0 degrees is freezing, and then 100 degrees Celsius is boiling. So, like a nice day is going to be around 20 degrees Celsius. Once you start getting to 30 degrees Celsius, that's quite a bit warmer. So we're getting above a hot day, and that's where you're going to get your gases. So this is where you're going to get your different heating oils, cooking oils, different materials for plastics. And generally, we're only going to have 1 to 4 carbons in there. So the general rule of thumb is the more carbons you have, the more energy you're going to have. Uh, Also, the more compact the compound's going to be. So like our gases are going to be gas, and then once we start getting to gasoline, it's going to turn into a liquid, and then slowly as we get higher and higher in our boiling point, we're going to get to residues. So like real sticky, sludgy stuff like asphalt or like motor oil, things like that. Uh, so yeah, you have your different fractions. As you increase your number of carbons, you have to increase your boiling point in order to get those different fractions out. So boiling point. So the boiling point of a substance is determined by the intermolecular forces between them. So what these forces are attractions of the molecules that is what keeps them together. So smaller hydrocarbons, so they have less carbon, less hydrogen, they're going to have lower boiling points because their forces are going to be weaker just because they don't have as many of those carbons and hydrogens to keep it together. Whereas the more hydrogens and carbons you have, the higher your boiling point's going to be, and the more energy you'll get out of it, and the stronger your forces are going to be. So hydrocarbons at the highest boiling points are usually going to be solids, and then those at the lowest are going to be gases, and those in between are going to be liquids. So make sure when you're doing your notes to write a summary. You want to have at least a couple of questions per page. Make sure to write a summary, and then make complete sentences or add anything to it, star, asterisk, anything that you might need that you think is important that's going to be on the test. A lot of this information, not a whole lot, not like any math or anything. It's going to be a lot of rote memorization. So just, know what a hydrocarbon is, know how fractal distillation works, know the idea that the more carbons I have, the higher my boiling point's going to be. Also, the higher the intermolecular forces, and that's why our boiling point's higher. But yeah, overall, when it comes to petroleum, just know what it is, know how it's made, or the different parts of it made, and just kind of understand how it's used. All right, guys, have a good rest of your day, and I hope everybody's doing well at home.